Here's a great example of another choice that we have with relation to color. And this is for our colorblind folks that exist out in our audience. They may not be able to see color, not the same way that we do, or the majority of people. Um, so, how do we account for that? We can print the same phenomenon in different ways. So, this is an example of the same geologic map set up differently. One on the left for those that are color sensitive, and the one on the right for people who aren't color sensitive, or if you're saving money, printing in black and white, which will be great for the color sensitive audience that can't see the colors anyway. All right. Um, so we're using the same, this is categorical nominal information. These are different geologic units shown in color on the left and on the right. We're using different patterns instead of color. The patterning or the texture of the symbols is indicating the different categories of geologic rock units, geologic types. Okay, they both do the same thing. They're both displaying the same information. We can see the differentiation between them. Maybe a little bit easier with color, but it's not too difficult to make them out on the grayscale black and white image on the right. It works just as well, but it works better for those who are colorblind than the one on the left. So there's again a choice that we can make, and we can actually mix those two things together. If you wanted to mix patterns in with the colors, if that didn't make it too busy, then you're solving a problem for everyone. The color sensitive folks will be able to see it. Those who can detect color are going to be able to see it. Those who can't will be able to see it just fine. That's something I'd be a little bit careful about making your image too complex, but it can be done if you're careful. Anyway, there's a choice that we always have with our digital cartography is, do we use color? Do we use patterns? Do we combine them? What works best and what's easiest for people to understand in the end is really what should drive what choices you make in terms of the symbolization, even at the categorical level. For a special type of a map related directly back to the point I made on quantitative maps, choropleth maps are where we have polygons describing areas, and we have a color applied to them, and the color indicates an increasing or decreasing amount of some variable, larger or smaller quantities. So here on the upper right, we have Oregon shown with some characteristic at the county level, using an appropriate color ramp in red to indicate distributions of that variable across space. On the bottom, we have a rainbow approach, which is to say we're just applying colors to these different polygons, to these different values. They don't necessarily make any sense. It doesn't really mean anything. There's no really good midpoint in a distribution that makes sense for using different colors. So that's inappropriate. That is not good cartography. We don't do it unless we're not trained in these principles. So this is something that I will look for sure when I'm scoring things in any class that I do. Is an inappropriate use of color ramp on quantitative data indicates to me that person didn't really put any thought into what they were doing and should be scored accordingly. This is just not a good approach to take in cartography. It's not science-based work. It's just schlock. So when you get quantitative data, by default, always be thinking about a single color ramp. Whatever color that is, there's not necessarily one color that works better than any other. There's some that may seem more appropriate to use, but as long as it's quantitative data, that doesn't, unlike temperature, temperature does have that nice middle point where you can say, sure, it makes sense to use blues and reds to indicate cold and warm. If it's most other quantitative variables, you really don't have that foundation to use, and you're stuck with using a single color ramp, which is great because that's what you're supposed to do anyway. That's the way. That's the best approach. So to kind of sum out this major topic of visual hierarchy, since we've hit on most of the points at this juncture, this is something that I use in discussion in the lecture class, and we talk about it and work through it, and we say, well, as the questions are posed, which map has a clear visual hierarchy? How do they achieve it? How do they make it work? So we compare and contrast the top map and the bottom map and take a look at it and see, what are the things that were done in each of those to make them either have a clear visual hierarchy or not. And so I'll walk through them. The points that I usually make and try to draw out from class is that the top map is using a lot of dark colors, which may work. That's okay. It's got a grid on it. The grid has been superimposed so that the grid is closer to you than it is. It's above the land surfaces and above the water surfaces. And so the grid becomes kind of the theme, and we're losing whatever's behind it. We've got a lot of background material and mostly a grid. Okay, that doesn't really work. If we're trying to look at the differences in color behind it, we've kind of messed it up a little bit. So when we look at the bottom one has taken the oceans from being a dark color and made it a light color. And on top of the oceans, we've pushed the grid by making it drawn underneath the polygons for the different continents, and we've made it a lighter color. So we've got a light blue for the oceans, a light color for the geographic grid of latitude and longitude, and then we've used that as the background, and now our countries and continents are floating on top of that background essentially. And we've got a fairly clear visual hierarchy. We've established the figure and ground relationship, where the figure is what we want to emphasize, the continents, and the ground is everything else. So the ground is the geographic grid and the blue oceans. By manipulating the colors and the orders in which they're drawn, okay, we've made that hierarchy work pretty well. And I hope this is a decent example for you so you can see, those choices that we make, as small as they are, as subtle as they are, they can make a big difference in how the map is perceived and how easy it is to use if you're the map user looking at this after the production. All right, so as you make maps, put a little bit of thought into them. What is it that you want to emphasize? What do you want to pop out for the reader? And how can you go about doing that? What are the little tweaks that you can apply to the symbols, to the color, all of those things in order to achieve that, to better make your map work? So let's take another look at visual hierarchy, this time by zooming in on an area around Portland in Oregon, along the Washington and Oregon border on the Columbia River. And so here we've got an example of a bunch of different things shown on the map. And how do we achieve a visual hierarchy here? And what are the different map elements that we can see and understand and how they're working on the map to try to get at that hierarchy and also make the map work? Well, first off, what you should notice is that there's a lot of text on this particular map. There's a lot of font use, different styles, different colors, and different patterning for different features on the Earth's surface. So the main focus being Portland is the largest and boldest, darkest color. It stands out more from the other text around. Smaller communities are not bold. They're done slightly smaller in terms of font size. Different features on the Earth's surface are shown in different colors. So mountains and rivers, when they're named, We're seeing things out there. Um, the purple colors are showing us the county names. Uh, we're seeing kind of a blue, green blue text for the rivers, and the text is kind of flowing and bending like the rivers along the river channels. We're seeing, what else do we see for color text? There's a state park out there. Okay. So text is being used quite a bit on this to show different things. And to show the mountains, it's kind of hard to see, but you see the NGE coming out of the bottom of the map. That's for the Cascade Range. So text is being spaced out across the geologic feature to indicate where the Cascade Range is and how big it is. We can only see a few letters from it. The other things that we can see out there on the landscape, there's not a whole lot of color on the landscape, but the river system is showing up as blue. We see a road network done in red and a couple of highway system numbers, Interstate 84, State Highway 205, I-5, and then we see the background, which is the landscape itself, which is kind of washed out, but we see indications of terrain. Okay, so this map is achieving that visual hierarchy. In this case, it's primarily done through text and different weights and colors to indicate different features out on the landscape until ultimately you reach the background, which is just that kind of washed out whitish, not quite grayscale in this case, but we're seeing those indications of terrain where the whiter areas are flatter, where we see more shadow that's indicating texture, indicating mountain ranges and valley systems. All right, so it's a pretty nice, well done little map for showing. Probably the purpose of this one would be city locations around the Portland metro area and some of the physical features around it. But it does establish a hierarchy, even with just a minimum number of things being shown, by varying those things in a logical way. A piece of a map that you should really never leave behind when you're doing map design is a map legend. You may not have a scale bar, you may not have a north arrow, you may not have a lot of things, but if your map has any complexity to it at all, if you want people to understand it, you should have a legend on it. And the legend simply explains what the symbols are. What are the different physical symbols? What do the colors mean? What do the different types of lines mean? The different hatching things that indicate area, what do those mean? If you don't have a legend that explains those things, then your map is pretty much worthless. No one's going to be able to understand it. Even if you have a nice title, that's great. But if you have more than 2 or 3 symbols on the map, people probably aren't going to understand it. So you have to include those things. And here's examples of maps from a voting representation, a key, which is another word for legend, a key that shows different types of cultural features on the surface, like hospitals, campgrounds, airports. Over on the right, on the top would be more of an exploration, navigation map legend that shows different points of interest on probably a recreational map. And on the bottom, something that's more keyed into science, the hydrography or water surfaces on the Earth. So river systems, ponds, lakes, things like that, different symbols for those. If you don't provide this information, then your map is pretty much just a drawing. Okay, the legend helps us understand and interpret the spatial relationships between these objects and what those objects actually are, or what those spatial phenomena or statistics actually are in space. So it's something we should spend some time thinking about during the map design process, and especially in ArcGIS, there's something we need to be aware of, which is the topic of the next slide. So one of the things you really need to pay attention to when you're creating a map in ArcGIS, when you generate a legend, every data set that's active at that time is going to be drawn into the legend. And you're going to be needing to do some hands-on work to fix the legend, to make it more legible, to make it easier to read. So we've got examples here on the left, a default map legend created by ArcMap, and on the right, one that's been modified by hand. So the default legend, when it comes out, is going to give you the names of the data sets as each major section of the legend. It's going to tell you what the variable is that's being displayed, what map symbol you're using, and the numbers that are behind it. And by default, you're going to get a mess. Okay, this is hard to read, hard to understand. It doesn't make a lot of sense to the audience that is not as familiar with the data set as you are. They don't need to be familiar with the data set. They need to understand what you're trying to show them about the data set. So what you can do when the legend is created, you right click on it and you ungroup it. And then you can modify these individual pieces as if they were different elements, as they would be on, like on a PowerPoint slide. So I can change the name of from cities.shape, meaning shapefile, change that text to read U.S. cities. I can change the POP 1990, which is the name of the variable. It's the header in the column in the table for the shapefile. I can change that from POP 1990 to 1990 population written out in English. Makes a lot more sense for your audience to read it that way. And then the final thing that's being done on this one is the numerical presentation. And so we can take those numbers, and instead of giving the default values that are in the range from the data set, we can change them slightly. So we're rounding them off, and we're inserting commas to indicate where we have the hundreds and where we have the thousands, where we have the millions places in the numbers, so they're easier to read, right? So take a look at those two, and which one would you prefer to read if you were looking at a map for the first time that was looking at 1990 U.S. population, the cities, so the major cities across the country. It's easier to read the one on the right, okay? But it takes a little bit of work, so you're going to have to think about that. Whenever you generate a legend, don't use that default legend. You need to modify it by hand and make it work better for your audience.